We now come to polarity of bonds, bonds becoming polar. Let's see this by an animated video. Polarity of bonds. Whenever there is formation of bond, the bonds are not equally shared. Electrons are not equally shared. There is difference of electronegativity. Now you see here Na and Cl. Cl has having high electronegativity. And Na is having low electronegativity. Even in case of water molecule H2O, the two hydrogen has less electronegativity as compared to one oxygen atom. So this is how there exists some polarity between the covalent molecules. What happens here, that hydrogen, the electron, the shared pair of electron is getting moved towards oxygen, because oxygen is more electronegative as compared to hydrogen. So this arrives the existence of polar covalent bond between the molecules. Also, this polar covalent bond is not only confined up to one molecule, it can go up to several levels. And this type of attraction between the atoms of different electronegativities in water is termed as hydrogen bonding. The hydrogen of one is attracted towards more electronegative oxygen of another. This arrives to hydrogen bonding in case of water molecule, which I will be telling after some time. But this is how polarity shows up in case of bonds. The bonds become more polar due to the electronegative difference. So like in a molecule of HF, if I say, then in HF fluorine is more electronegative. Fluorine is more electronegative. That means my electrons pair will go to fluorine as compared to hydrogen. The shared pair is not equally attracted. This arrives to the polar covalent bond. There is a quantitative unit called dipole moment to find out the amount of polarity between the bonds, and that is equal to Q into D or R. Q is your charge multiplied by the distance of separation between them. One dipole moment, the dipole moment is expressed in D by units, letter capital D. Now we'll understand concept very clearly with another video. What happens if I take NaF, F2 and HF? If I take NaF, then I am having Na and F, and the most electronegative atom is fluorine. So in NaF, what happens? Fluorine attracts this electron very quickly, and that's why sodium loses it very quickly. So there is formation of ionic bonding in case of NaF, a positive charge and a negative charge, and it got bundled up in a form of crystal to form the NaF crystal. Now come to non-polar covalent bond. See, if I take two similar atoms, then there will not be polarity, because the dipole moment will get cancelled out. In case of F2, if you look at the electron cloud, it will be same for both the fluorine molecules. For both the fluorine molecules, the electron density or distribution in the electronic cloud will be same. Now come to polar covalent bond. If I take hydrogen and fluorine, then of course fluorine is having more electronegativity as compared to hydrogen, and that's why the shared pair will get more attracted towards fluorine as compared to hydrogen. And this will make fluorine electron cloud as more electron supplement as compared to hydrogen, which has less electron density. Red shows here more electron and blue shows here less electron density. So it will acquire delta plus charge and that will acquire delta minus charge. This is what called polar covalent bond. In this part we have covered up the polarity of bonds which I was talking about. We have also seen a quantity called dipole moment in this part.